Okay, so we completed Docker in the last session. We'll integrate Docker with Jenkins later once we complete Kubernetes. So this is the automation we achieved with Docker and Docker or containerization. This is what we have done. What we have done is we have created the image using Docker, okay, for our Gamut card application. So this is your Docker Hub. So in our image, we bundled Ubuntu, JDK, Tomcat, and then the code, that is the WAR file. And we bundled a command which will start, Tomcat server. Okay, right. So it was clone, it was build. Third step was creating the image, push that image to the Docker Hub. Okay, this is the one. Gamut cart hyphen image, Gamut cart hyphen image. And fifth step, what we have done, we have executed a script. Remember, that is create environment.sh with set 10 servers. So if you if you execute this script with the 10, it will get 10 containers automatically for us. So we created 10 containers, assume for our production environment, and then we do the load balancer setup. Then anybody can access the application. So we have these 10 containers created from the image. So if you create the container from that image, we get a container which has operating system, JDK, Tomcat, code, and everything out of box. Dependencies plus the code. That's the advantage of containerizing our application. We are happy now. We're happy that we are able to set up the environment within less than few seconds. Within less than few seconds, we are able to provision the environment. We're able to set up the environment. That's the power of Docker images. Okay, fine. So once the environment is created, once the environment is set, then comes the maintenance things, operations, correct? And we face a lot of challenges, right? Once the environment is created, these are the challenges we face usually. See the first challenge, right? The first challenge that we face, assume that you need 100 missions, okay? In your production environment, you have 100 containers. 100 containers are there, okay? In other words, assume Flipkart requires 100 containers. 100 missions are there, servers. What if 10 containers go down? Possible, right? Because of the hardware failure, network failure, whatever. 10 containers went down. So how many you have? 90. You have 90 containers. Since you need minimum 100 containers, right? And you have only 90, as a result, what happens to me? Your application may become slow because you have only 90 servers versus 100. So question comes, how do you fix this problem? Because you're unable to run your applications with the same speed, right? You have less missions. So how do you solve this problem? A question, right? After the deployment, this is a question. So in earlier days, right, what we used to do, we used to set up a monitoring system. And we tell monitoring system saying, okay, make sure that you have 100 always. If if servers count is less than 100, you throw me an email. You alert me. So monitoring tools will send you the alert. Again, you pitch in, and then you create 10 containers, and then make sure that you have 100. Those days are gone now. Gone the days where you set up the monitoring system, right? You log in, you create 10 containers manually, blah, 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 and so on. So it's a, the lengthy process. By the time you add 10 servers, damage, when your business is already damaged. So the question comes, how do you quickly fix this problem? So in DevOps, there is a practice called self-healing. Not in just DevOps, but in automation, world, there is something called self-healing feature. You would have guessed by now, right? Self-healing. What is this? Self-healing means we automate our systems, processes in such a way that when there is a damage, system or software or our automation detects that there is a problem, and it detects that there is a problem, and it fixes the problem on its own. That's called as self-healing. There's a problem, system is able to heal on its own, self-healing. See the thing now, right? There is something called AI ops now, artificial intelligence ops, ML ops. Both are not same, okay? In AI ops, you know what we do? AI is all about predictions, correct? Inference, predictions, and so on. So these days, companies started, injecting AI in everywhere. That means AI will anticipate. It will predict that, okay, tomorrow, right? You are running a big billion day, or you have, tomorrow when you have, some extra activity or something is happening tomorrow, and system may fail. It will alert you. It will predict based on the patterns and based on the things that happen in your environment, in your system or processes or anywhere. AI ops. So you're predicting future, and then you are solving. So that is, even beyond this self-healing. It's AI who predicts the things. In self-healing, right? You are automating. If this is the case, do this. If that is the case, do this. It's like rule-based. You set the rule. If that rule is not working, then you give the formula, and then it works in that way. So this is like even beyond this self-healing and things like that. So this is again the new era. Leave that. AI apps and all the stuff for now. Things are not well matured there, but I'm just telling you the emerging, the latest automation practices that are revolving around, in the market now. Forget about that. So we need to have automation in such a way that if there is a problem, right, the system should detect that there is a problem, and then it should heal on its own, self-healing. So how do you achieve that? Tell me. If you are creating the environment like this, right, who will handle this self-healing feature? You have to handle, correct? To understand the point. So I'm just running this create environment.sh. I have 100 containers. Okay, fine. I'm happy that environment is ready, but who will handle this? You only have to handle this. And if you want to handle this, what you will do? you will have to again write some code, shell scripting, Python scripting, to detect that there is a problem, and if there is a problem, what to do and all that stuff. You have to write thousands of lines of Python shell scripting code. Again, you have to automate this, correct? You have to automate this. If you want that feature, you have to automate it. And if you want to automate it, you have to write a lot of code for that. Who will do that? You. And it's very difficult to write the code. Very difficult. It's not just writing the code, right? So you write the code and then your code may have some bugs. Again, you'll have to fix maintenance, right? And there is no guarantee that you'll write the code in optimized way. Right? There's no guarantee that you'll automate this in an efficient way. Depends, right? See the problem, see the challenge now that we face in real time. Since it's very difficult to automate, it's not that I'm not telling that it's not possible. You can, it's possible, but you have to write a lot of code, correct? That's where we call this person called Kubernetes. In short, we call Kubernetes as K8s. Between K and S, you have 8 letters. K8s, Kubernetes. If you have Kubernetes, you can achieve this self-healing feature, right? Self-healing concept very easily. Kubernetes is a person, is a tool who has this intelligence inbuilt, So if you have Kubernetes, you don't need to handle this, you don't need to write the code, blah, blah, and all that stuff. And Kubernetes is expert, right? It has efficient ways of handling these kind of things. Since Kubernetes helps us with these kind of things, we call Kubernetes as what? Orchestration tool, container orchestration tool, or container management tool. It is managing the containers, solving all these problems. So in real time, yes, we create the image. Once the image is created, once image is pushed to the Docker Hub, then we just forget about Docker. Docker's responsibility ends once the image is created. Done. Say bye to Docker. We don't need Docker. We don't use Docker, to run the, applications in environments. No, we don't do that. Docker's responsibility is only to build the image. That's all. Say bye to Docker. Then when it comes to setting up the environment, then we welcome Kubernetes. So I'll just push my image to the Docker, and then I'll say hi to Kubernetes K8s to create and manage the environment. How we will create the environment? Using Kubernetes. That means we'll be having our 100 containers running in Kubernetes, running under the supervision of Kubernetes. It is Kubernetes who supervises the containers. Means I'll push the image to Docker Hub, right? Then I'll not use this kind of tools. No, right? I need a specialist person to solve all these problems. So I don't create the environment on my own. Instead, I'll ask Kubernetes to pull my image. Kubernetes will pull my image. I'll give my Kubernetes. See, I'm not giving my Kubernetes to the, I'm not giving my image to the, very sorry. I'm not giving my image to the shell script, Python script, blah, 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 right? I'm giving my image to the Kubernetes. I'm asking Kubernetes to set up the environment for me. It is Kubernetes who is going to set up the environment for you. So once the image is pushed to the Kubernetes, once the image is pushed to the Docker, then we'll go to Kubernetes. Okay, Kubernetes is a person, correct? We'll say, hello, Kubernetes, this is my image. This is my image. This is my image. Please pull this image. Pull this image. Okay, please pull this image. And then create environment for me with 100 containers. I'm giving a state. I'm defining a state to my Kubernetes, desired state. What you want. You just tell what you want to Kubernetes. Hello Kubernetes at a very high level. Okay? You don't need to write the code. You don't need to write thousands of lines of code to achieve this. No, you don't need. Just tell Kubernetes. In a configure. In Kubernetes, we write something called YAML script. Okay, YAML. YAML is very easy to write. It's just kind of a configuration file. You just go to YAML file and then mention I want 100 containers. And then you run Kubernetes and then it'll make sure that 100 containers are created, right? Environment is set with 100 containers. And you're not, are you writing thousands of lines of code? No, right? Kubernetes has that intelligence. So as a fifth step, I'll go to Kubernetes and say, okay, this is my image. And then I need 100 containers. So I'm giving desired state, DS, desired state to Kubernetes. I want 100 containers. And this is the image, right? And I want load balancer, blah, 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 so on. Whatever you want, you just feed, give that information to Kubernetes in the form of YAML scripts. It can develop, it can create the environment for you. So who is creating the environment? Kubernetes. Okay, done. Kubernetes is able to create the environment. Since it is Kubernetes who created the environment, right? Kubernetes will also will offer some benefits. What are those benefits? Creating environment is simple, okay. And the other benefits is self-healing. So I tell Kubernetes, hello Kubernetes, make sure that I want 100 containers at any point of time. I want 100 servers. Kubernetes know that you asked for 100. That's a desired state to define, okay. We have already configured, right? We configure in Kubernetes saying, okay, I want 100. It knows that what you are required, what is required for you. And if there is any discrepancy between the desired state and the actual state, it will understand that there's a discrepancy and it will solve the problem on its own. Meaning, I gave 100, okay, and then if 10 containers go down, Kubernetes understands that you want 100 and the 10 containers are dead, and it will bring the 10 containers automatically for you without you doing anything, without any manual intervention. We call that as what? Self-healing. There's a problem. Kubernetes is able to detect the problem. It is fixing the problem on its own. We call that as self-healing. Okay, 1 second. Okay, so that is the advantage of having Kubernetes. So Kubernetes can help you with self-healing concept. Okay, it will help you, it will give you this feature. So we call Kubernetes as what? Orchestration tool or container management tool. Understand the importance of Kubernetes, right? And what Docker can do, and then what Kubernetes is offering. Any questions you have so far? Before we get into deep dive into Kubernetes.
Yeah, Kubernetes is it is like a script based one, right?
So before we deep dive into Kubernetes, I want you to understand the purpose of using Kubernetes. That's very important. See, this is what I always
No, I'm asking why only Kubernetes. So if not only Kubernetes, if any tool.
I'm not answering your question. 1 second, sorry. I'll take your question. 1 second, sorry. So this is what I always struggle to struggle to deliver. Okay, content, formulas, code, those things you find anywhere these days. Copy paste you can do, but the understanding process, the importance of something is very, very, very important. If you don't have that idea, you cannot design the automations. Okay, now, so that's the thing. That's the reason I'm spending a lot of time in explaining the theory. Otherwise, I could have directly installed Kubernetes and then start automation. Okay, so understand that. And yeah, Nagendra, go ahead with your question. Nagendra, question. Can you repeat?
Yes, Nashra. Actually, why we are using Kubernetes instead of any tool? Any tool can understand our requirement, right? Why especially we are going through Kubernetes? Suppose if another tool have, so we can give our requirement. The tool easily grab the conditions, right?
There is no other, the best tool in industry today which handles this. Kubernetes is de facto, not the only tool we have to get this done. There are other solutions, but those are not very, efficient, not very effective.
So
It
if
is the
if
market leader.
I write my own script, Naishwara, I write my own script like it is a shell script. So I'll design like the requirement, like how many containers we need. So those they can collect, right?
Okay. As I said, right? For self-healing, yes, that's what I was explaining, right? For self-healing, you can write your own code, shell scripting, Python code, and you can develop this, correct? So when we have a person who does this efficiently for you, right? Why you want to again do the coding, Nagendra? We want to do
So
code.
no need to invest for Kubernetes, right? I no need to invest the money for Kubernetes. I will go directly my script.
Kubernetes is open source; it's free. It's free. Okay, I'll tell you. It's not just about the money.
Okay.
So it depends on it depends on
No. I said we have older method scripting. So why we need to go for new one?
coming to that. Okay. You are writing your script to automate this. You don't want to use Kubernetes. See the problem number one. First thing, you have to write a lot of code, correct? That means you may need 5 people to write the code. That means it's a separate team. You have to form a separate team, tools team, for example, to write the code. First thing, a lot of cost is involved there. Second thing, you write a shell script, for example. Shell script, automating, tough tasks using shell is very difficult because shell is for the simple scripting. Okay, for these kind of things, you need Python. Shell is to automate simple things, right? You cannot automate, the complex things using shell. So, for example, you take Python. Today you have 5 people. Okay, you write the Python code. These 5 people are good. Okay, somebody leaves, from the team. Tomorrow you have to recruit the new people, right? New people. Is there any guarantee that the new person know Python? No. Okay, you recruit a person who knows Python, for example. See the cost involved there, right? So very difficult. That means you need to, have that knowledge, right? Fourth thing, forget about all these things. We manage with money, right? These things we manage with money. What is the guarantee that, right? Your team. What is the guarantee that your team, right, writes the automation code which handles this feature? It's not just this. Okay, I'm going to give you three other features. It's not just self-healing. Kubernetes can give you a lot of things for you. Okay, so whatever Kubernetes has inbuilt, if you want to automate, these are the things you face. So there is no guarantee that your team will write the code efficiently, right? Or does this automation in an efficient manner. Fourth thing. Fifth thing, it's not writing the code once, right? What are the maintenance? Maintenance means today your code is working fine. Tomorrow you change something in your application. You need to change the automation again. Again, something changes in your application. Again, you have to change your automation. So it's a continuously you need to maintain. Continuously you need to maintain this. It's not just about the maintenance. It's a lot of bugs. Continuously you need to keep adding new features. Okay, done. Say for example, there is some issue in the production, right? It's a big billion day. You have written a lot of Python code to do all these things, self-healing, blah, blah, and all the stuff. It's a production. You don't have time to fix. You don't have time to fix, right? You should be able to fix the things immediately. What if you don't have knowledgeable people in our team who can spot the the issue and then fix. And it's a code, right? You have to write the code, lot of code. You don't have time to write the code. You don't have time to find the logic. It's not just only one script, right? You'll be having maybe 100, 200 Python files talking to each other. So it takes a lot of time for you to fix the issue. Likewise, I can go on and then give you a lot of other reasons. So I don't write the script to solve all this problem. Instead, I bring Kubernetes now. Let's see how Kubernetes will help us. First of all, Kubernetes is completely open source. You don't need to write the code. Okay. And Kubernetes, okay, it's related to code. Okay, you don't need to spend money in forming a separate team. You use a lot of budget, and then you don't need to write code. You don't need to have this knowledge, right? Any dumb person can go to Kubernetes, for example, and then get the job done very quickly. You don't need to it doesn't demand much knowledge. How I'll tell you. Let me take some example. I'm just thinking for some example. You have a file, okay? You have a file. You have to copy this particular file from this machine to this machine. Mission 1, mission 2. You have a file. You have to copy the file from mission 1 to mission 2. Okay. You are writing some script, Python script, correct? You have to write the Python script for this, right? Assume that you are automating file copy from one mission to another mission. It's a procedural thing. That means you first have to write some code to connect the first mission to second mission, some code. Then before you copy, you need to check if the remote mission has the permission. You're copying this particular file in this directory, whether the directory has the permission or not. Then, right, you have to check if this is a binary file or if it's a text file or how to copy and things like that. Then you write the code to copy. Before copy, you need to write a lot of okay, you need to copy, right? Once the file copy is done, you need to again write the code to check whether the file is copied properly or not without any data loss. Checksum, right? If it's a 1 GB, it should have the same 1 GB. You have to write the code, right, to maintain the timestamp of this particular file. If you have some timestamp for this particular file, after copy also, it should maintain the old timestamp. How many lines of code you are writing just for a small thing? This is the problem. Assume that I have Kubernetes. Okay. In Kubernetes, we write the code using something called declarative syntax. What is that? Declarative syntax. This is procedural. You have to write the code. Right? There are two things. What you want, how you can achieve that. What is your problem? And then how you solve the problem. What is your problem? I want to copy file from one machine to another machine. How you solve it? Writing a lot of code. In declarative syntax, what we do? We just tell the system what you want, that's all. Only problem statement. Sorry. So in declarative syntax, right? Assume that you have Kubernetes kind of person. You don't need to write thousands of lines of code. You just tell what you want at a very high level, saying copy target path. Okay. Source, this is the file name. Mission, this is the mission IP address. That's all. 3 lines, 1, 2, 3. 3 lines versus 1,000 lines. How easy it is. So Kubernetes uses declarative syntax. I said YAML, right? So you need to just tell Kubernetes what you want, at a very high level. It has the logic. You don't need to write, your own code. No, it has the logic, and it is efficient. Okay, so Kubernetes uses declarative syntax. You don't need to write the script. That's how Kubernetes will help you. And Kubernetes is efficient I'll tell you how efficient Kubernetes is. Kubernetes was originally developed in Google as a homegrown product. It was used only within Google. Okay, it was a proprietary technology. Google runs millions, billions of containers, millions of containers. Say 10 million containers they need for Google search, Gmail, and so on. Now you see, when you have 1 million containers running, this is running application 1, this is application 2, this is running something, this is running something. What if somewhere some container go down? They have to track, right? And tracking something, some container somewhere went down, right? When you have 10 million, 1 million containers, you think, is it possible? Annually, very difficult. That's where they built a tool called Kubernetes with a different name. Okay, it was Borg in Google, BORG, Borg. That was their name. Okay, so they developed a tool called Borg, which is Kubernetes now, and then Kubernetes has the experience of running millions of containers. Now you see, imagine the experience of Kubernetes. It is that efficient. Okay, and I'm not given other problems. I'm given only one thing, self-healing. Okay, there are other things. So that is the reason we don't automate something on our own. Instead, what we do, we use Kubernetes. Okay, if you have Kubernetes, Kubernetes is very efficient, blah blah blah, and all the stuff. You don't need to maintain, right? It's an open source, right? When you need new Kubernetes, I mean, development team every day they will be, giving you new features for free every day, right? I mean, when I say every day, very free. So Kubernetes open source community is very strong. Okay, and you get all those features, bug fixes for free. Bugs you don't need to worry, right? And what is this? I mean, new code, new features, something like that. I don't know why I've written. I think understanding the code, right? Okay, fine. So in production, right, if it is your script, fixing something is very difficult, right? You have to understand the code, fixing takes a lot of time. It's Kubernetes, right? With the simple configuration changes, you can fix the issues. That is the reason why we don't write the scripts like this and then handle things on our own. Kubernetes is very, very, very efficient. When you have something already, you don't want to reinvent the wheel, right? Correct. So it is just that. I can go on and speak about the same thing for another 1 hour. Okay, but I have given very extensive thing. Nagendra, makes sense? Why we use Kubernetes? Why we don't write the scripts on our own? We can, but we don't when you have something. Makes sense, Nagendra? Any
Yes,
follow up?
yes. Yeah, I have one more. Sorry. As you said, it is a Google product, right?
Yes.
What happened when future Google stops this Kubernetes?
What happened?
Suppose Google stops this Kubernetes implementation.
No, the Kubernetes was developed by Google and then they open sourced it. They gave
Open source, if they
they gave
stop,
this they gave they gave this for free to the world, saying, okay, we have something great, and then we are giving, to the world for free. Use it, take it for free.
no, no. What I'm saying, this totally Docker and this DevOps concept is totally it is depends on this Kubernetes currently.
Yeah,
What happened if they stops?
if this stops.
Yes. Again, we need to go for old method.
No, 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 no. Good. It's not that simple, right? So let me open it. One second. If Google doesn't support, right, whole world is there, right? People like you and me. And a lot of when companies, when see, Kubernetes is used by almost all companies. If Google is not supporting, all these rest of the companies will come forward and then they will say, because their companies, their automation is depending on the Kubernetes, right? So they will say, take over. Okay, boss, if you don't want to maintain, leave it to us. We are there, because it is helping a lot of thousands, millions of companies. So it's not just simple. Google, in fact, it is not Google who is maintaining this. I'll tell you. I'll give the story in a second.
So that is one scenario. Another one could be, since it is open source, I think the source code will be, a copy of a source code will be there with multiple, competitors, and they can modify, like make slight modifications and, create another
Yeah.
open source tool. That is
Yeah.
also possible, right?
Yeah, correct. Yeah, the other point say this. So Kubernetes
Yeah,
is
and Google cannot come overnight and say, like, from tomorrow morning I'm blocking, like I am privatizing it. They have to.
yeah, that's what you have. It's an open source. You have the code, right? So you can modify it.
Yeah.
Yeah.
That's what.
So we don't.
Like how Red Hat is using this Ubuntu's source code and made it licensable like that.
Exactly. So it's not just one person. There are thousands of companies, who you are using Kubernetes. So you don't even one person. No need to spend time to modify the source code, right? It's a world. Thousands, millions of companies come together. They do it. Okay, one second. It's not even Google who is doing this now. Who is supporting Google? But yes, so there are like possible things. So you understand what is Kubernetes, right? It's an orchestration tool. So this is the history of Kubernetes. See the first line, okay? Don't read, just listen to me, okay? If you read, then you cannot understand what I'm speaking. Kubernetes came out of Google. Okay, see this. It was in Google, when they developed, they named it as Borg. Then they changed it as Omega in their own company. Then in 2014, they open sourced it. See, the companies, why should Google, need to, when they spend a lot of money, right? Why should they give something for free to the world? See, that's how, companies help others, right? If Kubernetes evolves, right, it helps Google also, right? In turn, they can also use the other thing. So people, contribute to the open source. So it's not that, always they don't always think shelfish. So they open sourced it in 2014, and then they handed over Kubernetes to another company called Cloud Native Computing Foundation, CNCF in short. It is CNCF who is maintaining Kubernetes now. It's not Google. For example, CNCF came forward and said, okay, yes, give it to us. I'll, manage. And it's open source, right? People work for free, correct? People contribute for free. But there should be some governance, right? There should be some authority. So that is CNCF now. Somebody should manage it, right? As a manager, right? It's a CNCF now. If CNCF withdraws tomorrow, the saying I don't want, there are n number of thousands of companies who is ready to take. And for us, it's open source. They also make a lot of money out of open source, right? So it's a free for us, right? And they also make the money. Even see, for them to maintain it, right? They also need some money, right? So they also make some money by issuing certification. For example, if you want to do certificate, certification in Kubernetes, you have to pay some fees, right? Some $30, sorry, maybe 30,000-40,000. So that goes to CNCF, and they use that money for maintenance and things like that. So it is the Google, CNCF who is maintaining now. And I said it has the experience of running millions of containers. And today, see that Kubernetes has the experience of handling your Gmail, Google Search, GFS. All these things are managed by containers, and then those containers are running on Kubernetes. See how effective it is. Kubernetes is written in a language called Go, or you call it a Go language. The Go language is again developed by Google only. Okay, so and this is the logo of Kubernetes. It looks like a steering, right? So it steers our application, driving, right? It drives the complete, the application with things. So I'll come to this slide later. I don't like to use slides, but when I prepared, I ended up preparing slides for Kubernetes. 1 second. So it is, it's not a problem at all for any open source for that matter. And we have the source code, in our hand. That's again flexibility. See, a lot of companies also do this. For example, Kubernetes has some features, right? I don't like those features. I take the code, I tweak the code, I like Venus said, and I can develop something on my own, right? That is only for me. So that's also there. Kind of advantages. Like that makes sense.
Yeah, yes.
Others, any other questions or anything you want to add on top of this?
Why it is especially using YAML?
Why it
Is there
is?
any reason? Kubernetes is using YAML, right?
YAML is famous now. It's not only Kubernetes. A lot of tools in the automation. You go to artificial intelligence, you go to machine learning, you go to testing, DevOps tools, any tool you take in current world software, all these tools prefer to use YAML because it's a very simple to understand, simple to write. That's the only reason. Because of its simplicity. It doesn't demand use programming skills to write YAML. That's the reason they would have chosen YAML these days for the compatibility reasons with other tools and stuff like that.
Yeah, got it.
Okay. Let's go back. So somebody has not understood these things 100%. Just don't worry. Okay. Few things come with experience, right? Don't worry if somebody has not understood. You'll learn. Don't know, just that means you have the less experience. When you get experience, in fact, you'll be able to gain knowledge more than me. No, no worries on that. For now, just you have to sometimes just leave. Okay, don't think too much about that. Whatever you understood, you understand. That's all. Remaining, just leave it. That's not very important for less experienced people. So self-healing, right? So that is the reason we use Kubernetes, because of all these advantages. The first problem is self-healing, and then Kubernetes is able to solve the problem for us. So I give the desired state. Again, see the thing, right? You are giving desired state to Kubernetes, right? I just explained. We give the desired state in YAML, and YAML is very easy to understand. And YAML follows declarative syntax. What's that? Declarative syntax means you just tell Kubernetes, hello Kubernetes, I want 100 containers, and then create 100 containers from this image, and then set up the load balancer this way. That's all. Very few lines versus thousands of lines. Okay, very few lines. So it follows a declarative syntax. So you just tell what you want at a very high level to Kubernetes in a declarative syntax, right? And then it will make sure that okay, your desired state is matching the actual state. That means I want 100. What is the actual state? How many you have actually? 90 or what? If it is 90, that means there is a mismatch. Correct? 190. So if the actual state is not matching desired state, then it will fix the problem on its own. Self-healing feature. Okay. So problem number 1, right? And then we are able to solve it. Kubernetes is helping us. Problem number 2. GDR. Zero downtime releases. Heard this name? Zero downtime release. You know this, but maybe terminology is new for you. So it's a production, right? You would have seen some websites saying, we are currently releasing the new code to the production, right? Website will be down, application will be down for another 2 hours, come back after 2 hours. Or they say smartly, we are hardly working for you. We are pushing some new features for you. Bear with us for another 2 hours or 3 hours. We'll come back. That means they're pushing the code, new code. While they push the new code to the production, their production environment is down. Their application is down. Zero downtime releases. That means without bringing the environment down, zero downtime. Okay, with zero downtime, can you release your new code? Without bringing environment down, can you release your new code? How do you do it? It's very important, right? If Insta, Facebook go down for 1 minute, people cannot live, right? Because it's not people, right? For entertainment, a lot of businesses depend on Facebook, Insta for ads, leads, business, a lot of things. And if it happens frequently, do you like to, would you like to use Insta, Facebook? No. If it frequently happens, you say, it's a crap, I don't want to use it, correct? So when you have critical applications like finance, banking, for example, you have like pharmaceutical, applications, downtime, is very bad for them, right? So how do you release the code without bringing environment down? Again, now you tell me. If you have to achieve this, yes, you can write the automation code, but very difficult to, write the code. Very difficult if you want to automate. Kubernetes has that feature inbuilt. Just tell Kubernetes, it is using this image, right? Say version 1 image, version 1, and then it has 100 containers. Tomorrow you have new image with new code. Just tell Kubernetes, hello Kubernetes, this is I want 100. This is the new image. Please create an environment for me. Kubernetes know how to, create 100 containers with the new image without bringing your environment down. It can, do that very easily for you without you writing a lot of code. So that is the reason we use Kubernetes. Second thing, okay, you push the new code, right? For example, you are running n code, you have new code n+1, right? So you have pushed the new code n+1 to the production. What if there is some issue now? Correct? What if there is some issue? So you want to roll back, correct? It will take time for you to fix the issue. So you don't want to, and we don't want to have issue, in the production, right? So you'll have to roll back to the previous one. How will you roll back? Again, if you automate rollback, it's like almost sometimes it's impossible for you to roll back. Few things. For example, you would have gone and changed the hardware directly. Or sometimes, few software application configurations are not reversible. See the problem now. Very difficult for you to roll back. Kubernetes can handle it very easily. And then auto scaling. If you have Kubernetes, right? If you are running your application in Kubernetes, Kubernetes can scale up, scale down the infrastructure based on the load. You can automate the auto scaling, scale up, scale down automatically, auto scaling very easily. Because of all these reasons, we run our containerized application in Kubernetes. So since it is helping us with all this, we call it as what? Orchestration tool or container management tool. And Kubernetes is very, very, very popular. Okay. If and Kubernetes resources are highly paid in job market today. There is something like, there is a special person who is expert only in Kubernetes. That guy is highly paid, right? So it's very important. And then tool, and Kubernetes works only with containers. Again, remember, if you're not using Docker, if your application is not running in the container, right? And if your application is not running in the containers, then you don't need Kubernetes. Kubernetes can manage only containers, not virtual machines, not other machines. It's only for the containers as of today. And it's a containerized world, right? People are going with the containers these days. So you have the application running in container means you cannot, leave, you have to, you need Kubernetes for sure. You cannot imagine an environment running in, environment with containers and then, there is no Kubernetes. It is, mandatory. So Kubernetes will be there. Containers are there means Docker is in use means Kubernetes is there for sure, almost 95%, 90%, say for example. And there is no other alternative to Kubernetes, the best tool we have now. There are alternatives, but those are outdated. That's the responsibility of Docker, Kubernetes. Okay, where we use Docker, where we use Kubernetes, why we use Kubernetes. Clear with this? Any questions you have so far? Okay, so what is Kubernetes? Kubernetes is an orchestration tool. It is there, the slides are there in our class notes. Kubernetes is also called as data center operating system because data center OS, right? People don't use this word, just leave it for now. Okay, I just gave some notes. Okay, what is Docker, right? You develop your application, you test your application, you build it, you create, the image, you do the testing, and once you want to deploy your code image in the production, then ask Kubernetes. Kubernetes will help you to create the environment. And this is the story of history of Kubernetes, and it is CNCF who is maintaining Kubernetes now. So if you want to do certification in Kubernetes, you can do this. There is something called Certified Kubernetes Administrator. There are different certifications in Kubernetes. Certified Kubernetes Developer. Okay. Certified Kubernetes Developer, Certified Kubernetes Administrator, CKA, CKD. There is one more thing. Certified Kubernetes Security Engineer, I guess. Security. We don't need all those things. If you want to do certification Kubernetes, do this. CKA, Certified Kubernetes Administrator. Okay. So if you want to do any certifications, right? Don't do certification in DevOps. I think I mentioned this long back. Don't do certification in DevOps. Instead, do certifications in tools wise. So immediately, if you really have time and then you want to, you prefer certifications and things like that, you can go and then do certification in Kubernetes. That will help, that will add a lot of value to your resume. Okay. In terms of package, a lot of things. Personally, I don't, go with the certifications usually, but I don't have any certification in any tool so far. I don't, prefer that, but yes, it's not that I'm not telling that it's not important. For some companies, certifications are important. Based on certification, they decide salary and a lot of things, but I never had to, show the certificates in my previous company. So I think that's the reason I never did any certification, but you can do it. That will add a lot of value. Okay, right. I just gave these challenges and then how Kubernetes will help us. I just explained all these things to you. Okay, see this. All these Kubernetes advantage, right? All these things, deploying the application without with zero downtime, self-healing, rollback, the auto scaling, all those things we can achieve with declarative configurations. Okay, so you just declare desert state of the system rather than executing a series of instructions, right? That means writing the script, thousands of Python lines of code. So for example, I'm declaring like this. You just declare how many containers, replicas, right, are required. Saying I want 3 replicas. That means I want 3 containers. It will create 3. I want 100. It will create 100 for you very quickly. It's not just about creating replicas, creating 100 containers, 200 containers, but we'll continuously monitor those containers to ensure that desert state, actual state matches the desert state. If there's any discrepancy, it can fix the issue on its own. Then comes Kubernetes architecture. Okay. Anyway, the slide is not there. If you want some theory, you can refer that. Okay. Shall I go and then take the new topic, Kubernetes architecture? Okay. See this. Please bear with me. I'll take the class for another half an hour today. So let's see, the importance of Kubernetes now. Okay. Let's see how you run. You must be curious to know, how I run our Gamut Cart application in Kubernetes, how it works. Let's understand that with the help of architectural diagram. This is Kubernetes architecture. Okay. In Kubernetes, you have something called master server, or you call it as control plane. Control plane, because from master only we control everything. So we call it a control plane or master. And then Kubernetes works based on master worker node concept. Master agent, like in Jenkins, we have discussed about master agent, right? Master slave kind of architecture it is. So I have node 1, I have node 2, and I have node 3. These 3 nodes are attached to the Kubernetes master. Okay. So it is master node concept. We call it as worker node 1, worker node 2, worker node 3. Okay. I call it as Kubernetes cluster. Know that? Kubernetes cluster. What is that cluster? Say this. In entire Docker sessions, this is how I shown, right? How we run the applications, correct? I have some containers. Do you run application on only one host? No, right? Correct. 10 containers. Okay, load balancer. So can you create 100 containers on only one host, one node? No, right? If this node goes down, all these containers are gone, correct? So we don't create containers on a single host. No. Instead, what we do, we'll be having multiple. Assume that Kubernetes is not there. Assume Kubernetes is not there. Without Kubernetes also, you can achieve few things. Okay, see this. So when it comes to running production servers, production containers, we don't run those containers on a single host. Instead, what I do, I'll take multiple nodes like this. Okay, like this. So I have, I call it the node 1, node 2, node 3. And then we form a cluster. This is called the cluster. Okay. Cluster means pool of machines. Node 1 is connected to node 2, node 3, node 2 is connected to node 3. That means all these 3 nodes are connected to each other, forming a single cluster, forming a single system. It's just like, think it as one computer, one machine. Okay. And then we create our containers on top of the cluster, not on only one node. I think somebody asked this question. I think I explained this in Docker class. Okay. So for example, assume that you want 100 containers, correct? Few containers are running on node 1, this one. Few containers are running on node 2. Few containers are running on node 3. Understand this? Assume that node 1 goes down. Node 1 goes down. 3 containers are running on node 1, correct? This 3 will go down, obviously, yes. Now, in Docker also, there is a tool called Swarm, Docker Swarm. What do you call it? Docker Swarm. See, I discussed about Kubernetes, correct? Few of these things can also be automated using this called Swarm. It is part of the Docker. Now we see. I said these days we use Docker only for creating the image, not for running the application, but Docker also has Kubernetes kind of implementation. That is this Swarm. Okay. Using this Swarm also, you can, Sorry, something happened. Am I audible?
Yes, Mahesh.
Using Swarm also, which is there in the Docker, If you install Docker, you will have this Swarm tool also, okay, inside the Docker. Using the Swarm also, you can do this self-healing and few things you can achieve. But again, that's an old story, okay? So before Kubernetes was open sourced, people used to use Swarm for self-healing and all the things. So Docker was, considered as powerful that time. Once Kubernetes came in the market, 2014, then people started realizing the power of Kubernetes, and nobody uses Swarm these days because Kubernetes is such a powerful tool. If you think Swarm as, Swarm may match, 20-25% of what Kubernetes has. If you think, Kubernetes is 100, right? Value is 100, right? Swarm may touch, 20% of it. So that's the reason we don't use Docker for running applications. Earlier we used to run, applications using Docker Swarm. So this Swarm, using Swarm, what you can do, you can create a cluster like this. Okay, you can create the cluster using this Docker Swarm. I call it as Docker Swarm. Okay, or think it as it using Docker. Okay, Swarm is a feature, one of the features in Docker. So I'm not talking about the Kubernetes. I'm talking about the Docker only. Okay, so if you have only Docker or before Kubernetes, this is how we used to run the applications. Instead of creating these containers, right, on a single host, we create a cluster, right, attaching multiple nodes, and then we create our production, containers on top of the cluster. So what happens if this node goes down? These 3 containers will go down, right, and this Swarm will create these 3 containers on other available nodes. That's how Swarm works. Okay, so we run our applications on what? Cluster. You can create the cluster using Swarm also, but this is not used these days, right? So that is the reason we go to Kubernetes. Okay, Kubernetes also has the cluster concept only. See this, it's a cluster. Just give me some time, you will understand. I know you must be having some questions now. You may be having some questions. Just give me some time. So Kubernetes also has a cluster, correct? How many nodes I have in my cluster? 3 nodes. So there is something called master and then worker nodes. Worker nodes are attached to the master. Worker nodes are attached to the master. I call this as 3-node Kubernetes cluster. How many nodes are there in your cluster? 3 nodes. We don't count this, okay? Because it is not running anything. It is not running your application. It is just a manager, controller. It just controls the things. It doesn't run your application. You will be running your containers on worker nodes. So yes, it's a 3-node cluster. So this is your Kubernetes architecture. On simple note, by nature, Kubernetes architecture is complex. When I say complex, not very difficult, but if you relatively compare this with other tools, you feel understanding Kubernetes little hard for sure. Okay, and that's how it is. Okay, so I need more attention from you. If you have any questions, feel free to ask me. It can be a very basic, simple question also. I totally understand, because see, that's what I do, right? Even if I'm learning something, I may ask silly question, right? So because we are learning, right? When I don't know something, any question, I may shoot silly question also. So I don't, we all understand that. Don't just leave the class with confusion. This is what my request is. Okay, done. So we have master and then we have worker nodes. Okay, right. In master, we have something called API server. There is somebody called cluster store. Here, there is something called scheduler. There is another component called controller. What is this component called? API server. This is called as a cluster store. It's a database, okay? So that means inside the master, there is a database. We call this service as cluster store. Cluster store. And it's a etcd database. etcd, people call it etcd or etcd, your wish. etcd database. You have Oracle, MySQL, MongoDB, right? SQL, a lot of databases, right? So Kubernetes uses etcd database, and it's a relational database. So don't worry, we never have to work at a database level. No, don't worry on that. So there is a database, and it's a etcd database. For interview purpose, just remember this. And then here there is something called scheduler, and then you have controller. Here you have somebody called kubelet. Here you have somebody called containerd. See this is how we pronounce it, okay? Containerd, D, okay? There's something called kubeproxy in all these worker nodes. In master, you have 4 people. Think that way, okay? 4 components, right? Think 4 people are sitting there, each having different responsibilities, okay? 4 people, 4 components, or 4 services. Components are services. In worker node, you should have 3 services, 3 components. That's how you set up your cluster. We are curious about how we create environment inside the Kubernetes, right? Correct? That's what we discussed here in theory. We are running 100 containers inside Kubernetes, correct? Under the supervision of Kubernetes. So since Kubernetes has a lot of features, we don't go with this Docker Swarm these days, okay? It's a Kubernetes now. In Kubernetes, how do you run our application? See this. Okay. Go back to our slide. Where is it? Okay. What are the steps? You develop your application, you write the code, you build the code, you create the image, you push that image. Once you push the image to the Docker app, then you go to Kubernetes, correct? So first step, I develop my application, writing the code. Then we build the code, correct? Using Maven. Build the code. Once the code is built, what do? We create the image, right? Which contains the code and then dependencies. Once the image is created, then we push that image to Docker Hub. Docker Hub. First, second, third, fourth. Assume, okay, something. Don't go with the numbers, leave it. So same thing, basically. Then I said, we go to Kubernetes. We tell Kubernetes saying, okay, hello Kubernetes, this is my image, and create an environment for me. It creates the environment. That is the theory, right? See, this is what we do. So once we push that image, right, we have image in the Kubernetes. Then I go to Kubernetes. That means going to the Kubernetes means you have to log in into your Kubernetes master. Okay, I go to Kubernetes. So Kubernetes is running here, right? Kubernetes is running here. I go to Kubernetes. Here, I have to tell Kubernetes, right? This is my image. I want 100 containers. I want load balancer, blah, 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 and all that stuff. That means you have to give the digit state, right? So now image is pushed. I want to create the environment. So I'll go to Kubernetes. I write this code, declarative syntax. No need to write lengthy shell Python kind of syntaxes and all this stuff. No. So I go to Kubernetes saying, I want this, get it done for me. I'm showing this here, okay? Same script. So here we read the script. This one I'm just showing you here, okay? So where do we go and then run the script? We place the code in Kubernetes master and then we run the script. The script will create environment for you, right? 1 second. One second. Sorry. So we go to master, right? And then we write this code, right? This is how we write the code. I told you Kubernetes understands YAML file, right? Remember, YAML file ends with YAML. These days, every day, everywhere it is YAML. You go to any AI tool, ML tools, these tools understand YAML, DevOps, testing tools, lot of them, because it's very simple to write. Like Maven understands XML, Kubernetes understands YAML. Think that way. I'll call it as deployment.yaml file. Deployment.yaml file name can be anything. Okay. So here I write what I want. Okay. What I want. So I'll say, hello Kubernetes, I want 100 containers. How many containers? 100 containers. Actually speaking, in Kubernetes, we call it as a pod, POD pod. We call it as a pod, okay? Inside the pod, we create the containers. Inside the pod, we run the, or we create the container. But for now, forget about that pod concept. Think that you want 100 containers, okay? You're telling Kubernetes that I want 100 containers. But actually speaking, we have to ask Kubernetes to create 100 pods if you want 100 containers. Just don't worry about that, okay? I'm telling Kubernetes that I want 100 containers. Done. Then to create the container, you need an image, right? Okay, this is the image, gamut cot-image. So image is already there, right, in the Docker Hub. So I'm going to Kubernetes. I log into this Kubernetes master and then I say, okay, I want 100 containers from this image. And then I want 8080 port, I want to expose 8080 port because Tomcat is there in this container, right? And I want to expose port number 8080. And then I want to create a load balancer. There are different ways to create load balancer. So I want you to create load balancer with, of this type, some type, okay? Don't think of too much about it, okay? I'm giving the digit state to Kubernetes that please create a load balancer in this way. What is that way? We'll explore that later. Okay, done. So this is how it looks like. Okay? Again, we write this same thing in YAML syntax, but I'm not following the syntax now. Okay, just take the concept at a very high level, and then we execute it. When we execute, there is a component here, API server reads our YAML file. This one, very simple. We draw this diagram every day in every class. I draw this diagram every day. If we have like 10, 12 classes, almost in all classes I'll draw this. By end of the Kubernetes, I can assure that you'll be able to remember this for sure. Multiple times I draw this, multiple times we discuss. Today, just take the concept. I'm okay if you don't remember anything in today's class, don't try to remember at all. That's okay for me. Okay, just take the concept. So image is created, and then there is a manifest file. I execute the manifest file using some command. So when you execute the manifest file, API server reads it. What is the job of API server? Reading your YAML file. That means it will parse your YAML file. That means line by line it will parse, and once the parsing is done, then it will read what you have written there, and then it will take that information to the database cluster store. It will store it here. Database stores it because it has to remember the desert state, right? Saying what is the desert state? You asked for 100 containers, and this is the image, and then this is the port number and things like that. So whatever you have, that information is stored in the database. Then comes this guy, scheduler. This guy takes the information from the database, read it, store it, then read it. This guy, scheduler, reads the information from the cluster store, and now this guy will connect to these worker nodes. How many worker nodes are there? 3 or 30 worker nodes, depends on number of containers that you want. So how many nodes, worker nodes we have in our cluster? 3 worker nodes. For example, you have asked for 100, correct? Now it knows that you have 3. It will split the load based on the resource availability. That means the round robin algorithm, right? That means you have asked for 100, right? So what it will do? It will get 100 containers. Yes, 100 containers. 100 parts actually speaking, but think it as a containers now, okay? How many containers it will create? 100 containers. There is a load balancer also, okay? So 33 containers on worker node 1. 33 containers on this worker node. Maybe 34 or whatever on this container. So it is creating 100 containers on few on worker node 1, few on worker node 2, few on worker node 3. Same thing here, right? In case of Docker also same thing happens. There's a cluster, right? If you ask for 100, few will be created on this, few will be on this, few will be on this. So here also it's the same thing. So 100 containers are created. If you have 10 worker nodes, it will distribute accordingly. And Kubernetes has that, but the intelligence, okay? It knows how much RAM this worker node has, whether this has less, whether this has more. So whatever worker node has more, hardware, it will schedule more containers on those worker nodes. Okay, now reads the YAML file, stores the desert state in the database cluster store. Then comes scheduler. Scheduler goes to any of the worker nodes. Assume that it will go to worker node 1. Okay. That means the scheduler guy, right? The component service will talk to this worker node with the help of kubelet. There's a component here. There's another person called kubelet. So scheduler talks to kubelet. The name of that person is kubelet. So it is the kubelet using which master talks to the worker node. Think it as kind of a agent software. Okay. So it connects to this. So scheduler connects to the kubelet. Okay. Saying, hello kubelet, I want 100 containers. This is the image. This is the port number. That means it is giving the requirements to kubelet, saying this is what I want. Overall 100 it needs, right? So for this worker node, that it will, it wants, it wants to run 33 of this. So it will say, hello kubelet, I want 33 containers from this image. This is the information, blah, 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 and all the stuff. So whatever information it has, it will pass that information to kubelet. Now, first thing what kubelet does is it will take the requirement from the scheduler, then it will download the image from the Docker Hub. Automatically it will connect. Who is the person Net component. What is the component which downloads the image in Kubernetes? Kubelet. Kubelet downloads the image. Ajunda 33. Okay, and it gives the image name I. Okay, number of containers and then image name. So this has the information, right? So then Kubelet downloads the image from the Docker Hub. It gives that image to another component called container D. What is that? Container D. See, if you see here, nowhere Docker is used. Okay, container D. Container D is like mini version of Docker. It's a stripped down version of Docker, a trimmed down version of Docker. It is a mini Docker. That means I'll explain more about what container D later. Okay, you'll get the clarity. But for now, think it as Docker kind of a tool which runs the which creates and runs the container. Okay, container D is a container runtime. Means it will create and run the containers. Okay, simple. I'll explain more about container D later. Okay. So scheduler connects to this kubelet, and then kubelet gives that kubelet downloads the image. It gives the image to the container D. Container D creates the container like this. Likewise, you have asked for 33, right? It will get 30 containers. Okay, let's see. It will create a container, and then once the container is created, then it will connect to this proxy. Okay, kube proxy we call it. Kube proxy or simple proxy. This kube proxy will allocate an IP address to this container. Container is ready. Actually, we call it as a pod, but I'm referring it as a container. That's okay for now. Okay. Until I explain the difference between pod and container, I'll be referring it as container only. But it's actually a pod. Forget about the pod. It is a container. So now you see. Now you understand, right? So likewise, kubelet will create 33 containers on this. Again, it will go and then talk to the kubelet. There's a kubelet here. There is a container D. Okay. And there is a kube proxy. So again, so this kubelet will download the image in this particular node. It will give that image to the container D. It will create the container IP. Again, it will go to kubelet. Again, it will go to this container. It will download the image in this particular worker node, right? And then you have container D. It will create the container and then proxy. So likewise, so 33 on this, 33 on this, 34 on this, whatever. And now if you see your containers, right, are running in Kubernetes, correct? This is a cluster, right? This is a Kubernetes setup cluster. So, sorry, this is Kubernetes cluster, correct? You are running your environment. You are running your containers on Kubernetes cluster. That means on Kubernetes servers, Kubernetes worker nodes in this case. So that's the meaning. So clone, build image, push that image to the Docker Hub. Then you go to Kubernetes master. That assume that this is master. Here I'll write this script. I'll execute this script. So this script will pull the image and then it will create the containers for me on the Kubernetes missions worker nodes. So now I say my environment is running in Kubernetes cluster. Correct? It is running in Kubernetes cluster only. And then it will not stop there, correct? It will create the environment. Then what? It will create the environment. Then it knows your desired state, correct? You want 100 containers. This is the image. This is the port number. This is the load balancer. It has the desired state, correct? Stored in the database, DS. So once the containers are created, then Kubernetes calls this person. There's one more component here, controller. It will ask controller to go and then monitor it. Monitor the actual state. So it will go and then check. Okay, this gets the information from the cluster, so database. Okay, 100. This is the image and blah blah and all the stuff. So it knows the desired state. So controller is connecting with the database. Okay. Then controller goes. It checks. Okay, are there 100 containers? Yes. It will come back. assume that 10 containers went down. For example, this worker node went down, some hardware failure. If this if this worker node goes down, so whatever containers running on this worker node will be down. So assume that you have only say 60 containers, for example. Okay, less containers. Now it understands, okay, I wanted, desert state is 100, but there is only say 60, for example, or 70, whatever. So the moment it understands, it will come back. It will come back. It will go to the scheduler saying, boss, this is the case, actual state. Actual state is not matching desert state. You need to take action on it. You need to take action. You need to jump in. Again, it knows, right? See, it has to create replacement. It has to get 30, containers, right? And it has all the details to create the containers. That doesn't need storing the information. It knows. Then again, it will take this image, hello kubelet. Okay, on other work, it will go to other worker node. And it will say, right, I want 33 more containers. You take 15, you take 15, for example, or whatever. Okay. So then it will go and then create the missing containers. And then again, 100, you have 100 containers up and running. We call this as watch loop. Watch loop, right? So it is kind of loop, right? It is checking and coming back and things like that. So controller creates a watch loop. Once the environment is created, controller creates a watch loop to check if the actual state is matching desert state. If there's any discrepancy, then Kubernetes will inform scheduler, and then Kubernetes will go and then bring containers. Replace the containers, replace the missing containers with the new one automatically. That's how you run your application, you run your environment in Kubernetes cluster. These are the services behind it. That's how Kubernetes architecture looks like. And then we call it as 3-node Kubernetes cluster. You want more containers, you need more worker nodes, because 8 GB, 8 GB, 8 GB, okay? 8 into 3, right? Say 24 GB for 100 containers. If you want 200 containers, you need more RAM, right? For example, so more worker nodes you attach, more RAM you will get, more CPU you will get. So more containers, more worker nodes you want. So that's how your cluster looks like. So I call it as 3-node Kubernetes cluster. 3-node Kubernetes cluster. Understand how, okay, you containerize your application using Docker, right? And you know when to forget your Docker. Once the image is created, just forget about it. Then go to Kubernetes master, and then execute the declarative syntax, the YAML file, and then Kubernetes will create the environment for you, okay, with given number of containers. And you have asked for the load balancer, right? So Kubernetes will also set up the load balancer for you. Load balancer name is flipkart.com. Done. And then anybody, when somebody types flipkart.com in the browser, it will come to this load balancer, and then you have 100 containers, 100 servers serving your application. So that's how that's how Kubernetes creates and runs your environment with all these features. So these days, right, we cannot imagine containers applications without Kubernetes, and then we use it almost mandatorily. So what I do in the next session is, now you know the architecture, we need to set up the cluster. That means I'm going to take a master, I'm going to take, the worker nodes, I'm going to attach the worker node to the master, okay? And I'm going to write the YAML file for our Gamut cart. I'm going to create multiple containers running Gamut cart, not like that create environment.sh, no, okay? So I'm going to create containers for our Gamut cart. I'm going to set up a real load balancer for Gamut cart. Then you also can understand our Gamut cart application from your network, from your laptop. Once we set up this public load balancer, we are going to do all that stuff. leveraging leveraging and implementing the different Kubernetes features. That is the plan. Okay, sounds great. I mean, any difficulties in understanding this diagram? You'll get clarity. As I said, every day we'll be discussing this, but I may not explain this in detail every day. Every day, same class I cannot repeat, right? We should not, correct? But I gave more details, insisting, on the concepts where we need to, put more attention. But yeah, so next subsequent class, I mean, in subsequent classes, I'll be kind of, I'll be kind of explaining the same thing at a very high level. You'll be able to remember it. But any questions you have? Guys, understand? Any questions? When any difficulties in understanding this? Any confusions? Please go ahead. Maharshi, Nazir.
No, sir.
Correct. Today, Rajat Kumar Naik,
Yeah, it's in Nagesh.
Sarvana, Shiv Kumar, Vineet, Triveni.
No doubts as of now, sir.
Able to follow? Able to connect to the Kubernetes?
Yeah,
Some-
it will take
yeah.
some 1-2 classes again.
Yeah, sir.
I today in today's class I tried mostly to connect you to the Kubernetes. Why Kubernetes? No, where Kubernetes comes. That is the focus.
Yeah, the first
that is
part
where I
was
focused.
quite comfortable. The second part, we need to understand the terminology.
Architecture, right?
Yeah.
It will take time. It will take maybe another 2-3 classes. Let's wait for it. Any other if you have any confusion, you can go ahead. Let's see.
So can we have class at usual time, like from 8?
Yeah, Nagesh, that will help actually. I was also about to, because 10:40, 11, it will be like
8:30.
if you're taking one hour class,
Earlier it was taking it 7:30. It is going to gradually increasing your pay.
See, I started a new batch recently at 7 o'clock, 7:30. That is the reason I had to postpone yours. I'll try to take at 8:30. 8:30 to 10. I'll leave at 10 at any cost. Okay.
Sir.
I'll stop at 10 o'clock.
yeah, fair enough. Yeah, thank you.
Hello.
Yes, Maharshi.
Sir, I have one doubt, sir. By using Kubernetes, we cannot create images, sir.
No, you cannot get the images. We need Docker for getting the image. See now, okay. So we use Docker today only for creating the image. Only for creating the image. Other than creating the image, we don't use Docker for anything. That means you write the Docker file, run some command, and then create the image. That's all. Okay. So Docker is like kind of, it's such a dying technology now. So after a few years, you may not see Docker at all, because today we use Docker only for creating the image, right? If somebody can create a mini Docker which creates only kind of a image, then you don't need the full Docker. So Kubernetes has its own capability of creating networking, right? A lot of things. So it doesn't depend on Docker, only for image.
Okay.
But so we have containers here, correct? This is the containers, right? Then if you don't know the container commands, you don't know how to log into this container. You don't know, how to start this container, blah, blah, all that stuff. So you need to, doesn't mean that, you should not learn Docker commands. You need the container management commands, whatever we discussed. It's just that we don't use Docker for this. It is Kubernetes which does all these things. Okay. I'll just undo it and then save the same image for tomorrow instead of drawing it again and again. Or okay, I'll write one more time tomorrow. so that you understand, things slowly. I don't want to say, I'll write it from scratch. Let it take time. So that's about today's class. So one more thing, okay. If somebody had not executed that project, Gamut Cart project, with the images, you don't understand Kubernetes at all. Later, if you don't understand me, please don't blame me, okay? So what you have to do is, if you have not done, at least before tomorrow's class, do this, okay? At least once if you are a busy person. So go to Docker. This is notes, right? So what you have done is, okay, this one. Just simply clone the code, run that min install command blindly. There's a Docker file, right, in our project. You create the image, push that image to the Docker Hub, and then create 10 containers using this shell script. Okay. So this is the thing, all these things, this Gamut Cart application, like Docker way. Run that, create environment.sh, create 10 containers, that's all. So basically, the same project I'm going to use here. Okay. But in a Kubernetes style. If you don't understand that project, then you don't understand Kubernetes clearly. Please do that. Execute that project once and then come back. Come attend tomorrow's next classes. And if you can practice Kubernetes daily, you can avoid a lot of confusions. Okay. So don't postpone. Today's class, it will take, if it's a 1 hour class, it will hardly take 20 minutes, 30 minutes for you to practice, right? Just to execute. So today's class, you execute tomorrow and then attend next class. Practicals, so that you won't get confused. Because I said Kubernetes is a little complex. Don't worry. I'm here to explain, to simplify the things. That's my job. And I'll do at my level best to simplify the things, okay, with real-time analogies and stuff like that. So I'll give this to you. That's my job, and then you do your job. Daily practice, and that Gamut Cart project executed at least once. So if you do that, and then if I do this, then we can get max out of it. Okay, let's do it. Okay, that's all the notes from my side for today. Please follow those things. Okay, later don't blame me that I have not understood this blah blah and all the stuff. Okay, but ask more and more questions. That will help you a lot. Okay, done. Any other questions for me today?
Sir, it's Rajat here.
Tell me.
I have one small request, sir. Is it possible to have any additional class for doubt clear in weekends also? Because what the issue I am facing is mostly at during 8, 9, 10, at this period I am mostly in office and I'm not able to talk at that particular place. If even if I have doubts, I cannot prompt in the this kind of classes and all. So is it possible to have any extra or within a 15 days a weekend classes so that if we have any doubts, so we can clear over there?
Let's do this, Rajat, because I don't know, people don't attend even if I have the separate class. Let's do this, okay? Every day after the class, I'll wait, I'll be there in the class only for you for another 15-20 minutes, or for other people to practice. Is that fine? Daily 15-20 minutes I can stay back. For example, today, right? It's late today, but say for example, after the class, I'll stay 20 minutes. Whatever doubts you have, if you want to practice in front of me, you do it. I'll wait for you. 20 minutes I'll give you.
Actually, the issue that I'm facing is my office time is the night shift only.
Okay, you're taking the classes from office. You are still in office
Yeah,
now?
that's the reason. Even if I had doubts, if today
Okay.
I'm work from home, that's why I'm talking with you. Otherwise, if I'm there in the office, I cannot able to speak also in front of everyone.
Then
So
let's do this. you take the responsibility to remind me. Okay, Friday, let's try to have a practice session for all, but you have to remind me. Is that right?
Okay, sir.
Okay, guys. So this Friday, 1 hour, maybe half an hour, 45 minutes class or 45 minutes practice or whatever. I'll take the class also, but practice also. For practice, I'll spend 45 to 1 hour this Friday. Class also will be there, but on practice, half of I'll split. And whoever wants to practice with me that 1 hour, anything is, it need not be Kubernetes. Starting from the day 1 to till Friday, whatever you want to practice, do that in the class. Okay, Rajat, Friday. Can you remind me before starting the class?
Yes, sir. Yes, sir.
Okay. Thank you, everybody. Good night.
Yeah. Yeah. Thanks, sir. Have a good night.
You too. Bye.